I've spent most of my 23-year career on the JVM, and it seems like every week someone is trying to proclaim Java dead, saying it's ancient, too slow, too verbose. However, these claims couldn't be further from the truth. Such comments usually come from people who don't have a lot of experience with Java or maybe haven't touched it since CS 101 15 or 20 years ago. Now, Java's been around for 28 years, so yes, at some point in time, some of those comments could have been true, but they are not true today. Today, Java is one of the most popular programming languages on the planet, and it's used to run half of our world. So what I want to do today is create a new project in IntelliJ. This is going to be really good for new beginners or anyone who's been around Java for a long time. And we're going to take a look at some concrete examples. I want to start with it's too verbose. And again, if you write Java like we did 20 years ago, maybe it is. But I want to take a look at some features in the language that make it not verbose. Things like a new JEP for unnamed classes and instance methods. We'll take a look at the var keyword. We'll take a look at records, string templates. We'll take a look at text blocks. So I'll show you some examples of how Java is not too verbose. And then we'll dive into this really cool project called the 1 billion row challenge and how Java is not slow at all. So with that, I'm going to jump into my IDE here. I'm using IntelliJ. Nothing that we're doing here is specific to IntelliJ, so feel free to use anything else, Visual Studio Code, Eclipse, whatever you want to do. So I'm going to create a new project here, and we're going to jump in here and give this a name of Java is verbose, right? And I will leave a link in the description to this repo that contains a nice README of all the things we're going to go through, as well as some of the source code. So I'm going to put this in my downloads. Let's say downloads. And what we're going to do is we are going to use Maven. We're going to use Java 21. One of the features I want to look at is a preview feature in 21 and 22. And then we'll say, what is our group ID, dev.danvega, and the name of the artifact is Java verbose. If you're really new to Java, and this looks a little strange, what we are doing is we're not just creating an empty Java project, we're creating a Maven project. Maven is a build tool in the world of Java, so is Gradle. We could talk more about those on this channel if you like. If that's something you're interested in, leave me a comment below. So now we have this new project called Java Verbose. We'll go ahead and hit create and open this up in IntelliJ. All right, so here we are in IntelliJ looking at this project, and this is the POM, so we're using Maven. This is where we kind of declare our dependencies. We aren't going to bring any dependencies in today, but as you can see, we are using Java 21. Now, there might be one thing you have to do to take a look at this first feature. Whatever text editor or IDE you're using, you can set a language level. So I'm setting this to 21 with a preview. So I want to use a preview of basically one of the JEPs that is in the README today. So the first complaint that I hear is that Java is too verbose because of public static void main, all this kind of ceremony you need to create your first class. So let's talk about that. I'm going to create a new class called application. This is a class. It has a public class application. Now, normally I would put this in a package too, so I might do something like dev.danvega as the package. Move this in here. Yes, refactor it. So now I also have a package declaration. And just to kind of write my first method, I would say public static void main. There's a little shortcut in IntelliJ to do that. And I would system.out.println hello world. So there's a lot of ceremony going on here, but I understand this complaint from new beginners to the language because there's a lot of cognitive load here, right? Like I need to understand what a package is. I need to understand what this access modifier is. Everything's got to belong in a class. Here's the class name. Then I have this method that here's another access modifier. We're declaring this static. What are we going to return from this? Void. The name of the method is main. What is this going on in here? Well, this is an argument saying it can accept a string array, and that argument name is args. And then if I wanted to, I could pass some args into it. So yes, there is a lot going on here for someone brand new to the language, but for anybody who's using Java day to day, this isn't something you got to type a lot of because there's only one main method in Java, right? So we're not doing this a lot. Now, I will say for new beginners to the language, there's a way that we can cut down on this. So what I'm going to do is actually drag this back out. I'm going to go without a package for now, just to clean things up. And I can also get rid of my class here. So I could say I don't need that. I can come in here and say I don't even need public static. I can say I don't need this string args. And we can say that we can strip all of that down to not have to worry about that. Now I think I need to set the language level, but I thought I did. And now that we go ahead and save it, now we're left with this. So we have void, main, and then some print line message. So now from the ID, I can go ahead and run it, and we should see in the console, hello world. So now, as a new beginner to the language, I can come in here and say, oh yeah, I want to play with this. I want to like write some code. So I heard that I could say int a is equal to 10, int b is equal to 20, int sum is equal to a plus b. Let me go ahead and print that out. And now I can go ahead and run this again. And now we should see that we have the sum down there, which is 30. So now I get this. This makes it a little bit easier on someone new to the language, but this is really for just getting started. After that, we have this one public static void main method that is the entry point to the application. So that is number one. Again, I have a link to the JEP in the README below. This is really around unnamed classes and instance methods. Okay, so sticking with this, I'm going to leave this main method here, and we're going to talk about something else that helps cut down on some of the verbosity. So people see some code and they go, oh, this is Java, this is so verbose. And I want to talk about a solution to some of that. So I'm going to write a simple client that talks to a JSON placeholder service. And we're going to look through this code, and as we can see at first glance, maybe it does seem a little too verbose, but there are some improvements that we can make to it. So I need something in the JDK called the HTTP client. So I'm going to say HTTP client dot new client. So I'm going to say new HTTP client, and I'll say dot var, and this creates a new variable called HTTP client, and there's that. So with a client, I need to basically have a request to send in there. So I'm going to say HTTP request dot new builder. And what we're going to set here is a URI. So we're going to say, hey, URI dot create, and we need a string here. So I'm going to say HTTPS, and that is JSON placeholder. Yep, that's it. Then I'll just go ahead and build that, and that will return me a request. So I'll say .var to set up a request, and so far so good. Now, what I'm going to get back from that is a response. So I may say HTTP client.send, and in there we will pass in the request, and we will say, what are we going to get back as the response? I'm going to say HTTP response dot body handlers dot of string, right? That'll work. And then I can go ahead and return the response. So that is an HTTP response of type string. We need to go ahead and add an exception for this. And then finally, I can go ahead and S out the response.body. So this looks pretty good. And if we run this, we see that we get a list of 100 posts. That looks good. Now, I want to kind of clean this up because, again, looking at this, what we see on the right side is the actual call to the class. In this case, I'm creating a new HTTP client using a static method. On the left side, we declare this as an HTTP client with the name of HTTP client equals HTTP client. So this code right here, yes, we can improve upon this. Instead of having to declare the type here, we can just say this is going to be a var. We are going to infer the type from whatever the right side of this equation is returning. Again, here we can say var request. We don't need to know any of this. So just doing that simple thing by using the var keyword that came in JDK 10. So if you're on JDK 10 or later, you can use this. Just by using the var keyword, we've cut down on a lot of that verbosity. So I think that is kind of number 2 for me, making sure you're taking advantage of using the var keyword. All right, so next what we're going to do is we're going to take a look at records. So let's start with a normal class that we might create. So we might create something to represent a to-do in our system, and this is going to be a class. So we come in here and we declare some variables. We might say, hey, we need an integer, which is user ID. We might need something that is an ID. We might need a title, and we might need a Boolean completed. And in this case, I'm actually going to set this to Boolean, so we can default this to false. So next, I might need a no args constructor, so that's a good one. I might need an all args constructor, so I can create an instance of this to do with all the arguments passed in. You could have some different constructors in between that. Then I need to get getters and setters for each of those fields, so I can go in and generate those. Then I might need an equals and hash code. So I can go ahead and create that. So now I have an equals and hash code. And finally, I might want a toString to represent what a to-do looks like when we want to go ahead and display one. So here we are, 77 lines of code for a simple data carrier class that has 4 fields. And obviously, the more complex this gets, the more code we're going to write here. Now I generated most of this, but anytime something changes, I got to come back in and regenerate it. It's kind of pain in the butt, right? So let's look at the first way to improve this, which is to get rid of all of this code. We don't need that, right? So what we can do is we can use something in Java called a record. So a record takes in the components of that particular record, similar to the fields of a class, right? So I can say integer user ID, integer ID, string title, Boolean completed, right? And that's it. That's a record. No 77 lines of code, just a simple declaration of what your record is going to look like. Now, this is an immutable class. This means that once we go ahead and create an instance of it, we cannot change a value in it. We would need to create a new instance of it. This is good. This actually, there's a lot of pros to dealing with immutable classes. But I just want to take a look at an example of creating this. So let's go ahead and get rid of all of this. And I'm going to say var to-do is equal to new to-do. We're going to pass in a 1, a hello world, and then is this completed? I will say false. So you see that we've created a new instance of our to-do, and I'm going to go ahead and print this out. But Dan, we didn't write a toString function. That's okay, because underneath the hood, the record is doing this for us. It creates an equals and hash code. It creates a constructor. It creates the getters for each of the values in there, and it creates that toString. So if I wanted to just get a particular value, I could say sout to do that title, and now we can go ahead and just see the title. So that is a record, really cuts down on a lot of verbosity of just writing out simple data carrier classes. All right, so I'm going to get rid of this. Something else I want to show you is I'm going to revert back to that long class. Let's do that. And if we go down here, we can see that we have something here representing a to-do in our system, but it's using this pattern of being able to, this is a string literal over multiple lines. And this is kind of ugly, right? Like this doesn't look easy to write. I mean, it doesn't matter. I generated it, but I want to convert this into something using string templates. So I'm going to say replace with string templates. And now you can see we use this str dot. And now anywhere we use a backslash, we are saying this is a variable. Go ahead and replace it. So now we've kind of turned all of that clunky code into a single line that looks much easier to read if you ask me. So that is string templates. Now I want to show you one more. I'm going to go in here and I'm going to create a new Java class, and maybe I'll call this my to-do repository. And this to-do repository is responsible for talking to a database. So I might have a method in here called list that is going to return a list of those to-dos, and it might be called find all. Now, the first thing I might do is write some SQL. I'm going to paste some SQL in here, and this is how I use that kind of multi-line string, right? This is a string literal saying select ID, user ID, title, completed from to-do, but it's very ugly to put on multiple lines, right? Like this is not friendly to read. So what I can do is actually use the triple quotes. And now what I have is I have a nice area where I can just type out multi-line strings. So I can say select, let's say ID, user ID, title, completed from to do. And then what if I wanted to like just say where, I could do more stuff here. So this is really nice to do. And actually, if I wanted to even like format this a little bit further, I could do something like this. So now I can just say return list of, we're just not going to return anything here, just for example purposes. But now I have this nice formatted string on multi-lines using something in Java called text blocks to give us that nice readability. And again, the purpose behind some of this was to show you some of the examples where people say Java is verbose and kind of debunk that and say there are better ways to do that in Java these days. All right, so this next one I want to look at is kind of debunking the myth that Java is slow. This was a really great project put together by Gunnar Morling called the 1 billion row challenge. And if we look at this, there's a whole bunch of entries in here, but let me get down to the README. And this says, here's some status updates. The 1 billion row challenge is a fun exploration to how far modern Java can be pushed at aggregating 1 billion rows from a text file. Grab all of your virtual threads, reach out for SIMD, optimize your garbage collection, or pull any other trick you have to create the fastest implementation of solving this task. So there's some information on the text file and like how to pull from it, some examples. But what Gunnar was going for was really trying to find out who can come up with the fastest way to solve this problem. Now, the first three results, most of the results at the top here are using something like something called GraalVM. And this allows you to take a Java application and compile it down to a native executable so it runs on that machine. It doesn't need a JVM in place. This gives it a much faster startup and allows it to kind of start running right away on whatever native machine it's working on. So we'll get to the Java stuff in a second, but even just from this GraalVM, being able to compile down to a native executable, 1.535, 1.58 seconds, 1.60, all around 1.5, 1.6 seconds to read in a billion rows of data. That is impressive. I don't care what tricks people are pulling out. Other language communities have pointed to, well, Java's doing all the tricks of the trade. Whatever, they're available to your disposal. If speed really matters, then there are things that you can do to speed up your application. Now, that's impressive, but I also want to look at right past those first three, there is an open JDK one. So this is not using GraalVM. And again, you can look at the examples of these and see how they did it. But this one is doing it in 1.8 seconds. So just Java, not being compiled down to a native executable, is able to read it in 1.8 seconds, a billion rows of data. So yes, I understand this is like a special challenge and people pulled out all the stops to make this happen. But this is to show you that you can write very performant Java. Now you can also write slow Java. There is, the tools are there to be able to write performant Java. But if you want to kind of stick to some old ways and do some things that are not performant, then you can write Java. You can write unperformant code in any language, even Java if you wanted to. So I thought this was a really good challenge. I want to go ahead and leave an example of this in the description below. But if you're interested, check out the 1 billion row challenge and check out some of the ways that these individuals were able to get it to run so fast. All right, that's our tutorial for today. Again, people will tell you Java is too verbose, too slow, it's dying. Couldn't be further from the truth. Java's been around for 28 years now. It is running half the internet, and it's one of the most popular programming languages on the planet. I'm obviously a big fan, but I am here making this video to make sure that you understand that these people who are telling you that Java is too verbose, they're all lies. Again, it may be coming from past experiences, way in the past, but I'm telling you there are ways that you can improve really any programming language, but here we're talking about Java today. So, hey, I hope you found some value in this, friends. If you did, do me a favor, click that thumbs up, subscribe to the channel, and as always, happy coding, friends.